Hi, I'm Sarah Zatko, and I'm going to be talking about the way we approach computer science education as a whole and how security fits into that. And I'm going to use environmental engineering as a model for how we could approach integrating security into greater computer science curriculum. To start with, of course, you always start with the problem. So, what's the problem here? Well, I mean, there's a lot of them, but the one I'm focusing on is we always talk about how there's this inherent asymmetry in computer security that benefits the attacker, that they just have to have one success in order to win, but the defender has this huge attack surface that they have to defend. And that sort of asymmetry is inevitable in any sort of attacker-defender scenario, but we amplify it tremendously in the computer security domain by the way we approach these things. In particular, the attacker mostly gets to focus on just crafting that attack and getting it to work, whereas the defender has to spend 90% of their time, probably at best, just focused on fixing stupid things that shouldn't have happened in the first place, rather than working on actually defending their system and like those big problems. You know, that you can have the best training in the world, but if you're just always doing janitorial work, fixing all the stupid mistakes that shouldn't have happened, then, you know, where are you? And that's the problem we have here, you know, that we don't let the defense security experts actually do what they do best. And the main reason why these stupid mistakes keep happening isn't because people like to mess with us and make our lives miserable. I mean, people aren't stupid on purpose usually. It's that they weren't properly educated. They didn't learn the security basics, so they keep making the same mistakes over and over again. And I refer to this as the security afterthought problem, that it's just people don't think about it, and so then, you know, that we keep repeating history. But we talk about security like it's an important thing more and more. You know, everyone talks about how we need more experts and we need better security and blah, blah, blah. And if it's such a big priority for everyone, why does it continue to be such an afterthought when it comes to actual design and deployment? So, you know, that's the base question, because, you know, you can't fix a problem until you know where it comes from. So, I believe that the reason why security is such an afterthought in, you know, the real world and in the way these systems get built is because it was taught as an afterthought. The majority of undergraduate computer science programs do have some security content, but it's usually specialized material that's meant for future security experts. The students that are interested in security have to seek it out, and usually they end up taking those courses like junior or senior year. And that's all useful for creating future experts, which we need. But the other students who don't see the role of security, the need for security in their work, who, you know, just it's not their priority, they can easily get through all 4 years without getting any security content. And, you know, the security isn't just the domain of security experts, it's everybody's concern. And so, you know, that's the big gap. Because like some employers have recognized this problem, that their incoming recent graduates don't have the necessary security content, and then they have training courses for their new programmers to try and address this. And that's, I mean, better than not having it, but it is course correction. They've already spent 4 years doing their homeworks and all their assignments with all these bad habits, and it's hard to change that once somebody's built up all the bad habits. It's much better to teach this stuff correctly from the beginning. So, first, before I go any further, I made a lot of assertions about how computer science gets taught, and I always like to have data to back that up, because I'm a math major and I like having numbers. And so I sent a survey out to 100 different computer science department heads, got 33 responses, which is pretty good for just, you know, cold calling people. And I was focused on gathering data about how security is prioritized and integrated into the undergraduate curriculum. And if you're ever doing a data collection effort like this, I highly recommend this book, The Psychology of Survey Response. Apparently it's sort of the Bible for survey design, and it's very useful for figuring out how to get the info I needed with minimum bias and minimum effort on their part. That last bit's important because if your survey's too hard to fill out, they won't do it. But anyways, so on to the data. The first question I wanted answered was, how is security ranked with regards to other subjects? So I sent them a list of, I gave them a list of 10 different computer science topics. And, yeah? Are you waving at me? Oh, okay. I gave people a list of 10 computer science topics and asked them to pick the 5 that are most important to include in undergraduate curriculum. So you can see those topics listed along the x-axis, and then on the y-axis we have how many times each topic was included in their top 5. And yeah, compilers didn't do well at all. So algorithms and data structures coming in at number 1, not surprising. Software design's number 2, but yeah, security's down there at number 9, just after AI and just ahead of compilers, which isn't great for security.
We lost the other.
Yeah, that was the writing category.
There's somebody sadder at a compilers conference somewhere.
Sorry. And then I had the second, this was an important question, so I asked it a couple ways. The second way was I gave them 6 topics and had them order them in order of importance, with 1 being most important, 6 being least. And so you can see those rankings on the x-axis, and then on the y-axis it's how many times each topic got that ranking. So algorithms and data structures is almost overwhelmingly first. Software design is almost always second. The rest of it's sort of a mess, but security comes in 5th more than anything else. Yeah, computer architecture is the one that came in last most often. They skipped rank between the previous graph and this one, which is a different thing, but I'm just a data nerd. Let's see, if you look at that same data a different way with like just the average rankings that the topics got assigned, algorithms and software design are 1 and 2, security averaged 4.7, so solidly 5th. And another question is how well is security integrated into the curriculum? Because if it's not highly prioritized as its own subject, well, maybe it's just integrated into those other subjects. Maybe that's how they get the security content. So I had them rate the security content in their core undergraduate classes from totally separate to totally integrated. That's the x-axis. And then y is how often a particular rating was assigned. So 22 of the 33 responses said that it was either totally or mostly separate, and only 2 said that it was totally integrated. So they're not getting their security content that way. And then my third question was how applied is the content? So for a couple different topics, because I don't want them to know I'm primarily interested in the security stuff, I had them rate the content in their curriculum from mostly theoretical to mostly applied. And that's the y-axis, where it gets more applied as you go up. And then I graphed that data for security against the integration data, and what you can see is like the integration increases as x increases. So as the security content gets more integrated, it also gets more theoretical and less applied. So, it's a subtle trend because people mostly like to assign mid-range numbers for this, but it's definitely there. So where does that leave us? So security is not highly prioritized on its own, nor is it integrated into the other content. And when it is integrated, it tends to be in a diluted form. It's less applied and more theory. So none of that's great, but also none of it's a surprise. But it's still nice to know for sure where you are. Right. So, and I'm not saying that any of the other topics I mentioned should be thrown out for security. They're all very important topics. And we usually do have a specialized security track and specialized security courses, and those are doing what they need to do, helping us create future experts. But every computer science topic has security facets to it. It's a natural component of all of these courses, but we're just not used to teaching it that way. And that's what we need to do here, is just take the flip side of all these coins. We always focus on the how does it work and how do you use it, and we need to put the how does it not work and how shouldn't you use it back into all these other topics. Just because we're used to teaching these things a certain way doesn't mean we should keep teaching them that way. So what about integrating security into all these other courses? You get pushback on this because this does involve a pretty drastic redesign of your overall curriculum, but sometimes doing the right thing is hard. And and I really believe that doing this sort of redesign would have huge benefits. And why do I think that? I do have a bit of a existence proof here. So, what corroboration do I have? It's in the environmental engineering domain. So, if you step back, environmental engineering and security actually have pretty similar origins as fields. In both cases, we realized that we had a lot of problems of a particular type, and then retroactively sort of created a specialty to try and deal with those problems. So in both cases, the fields themselves were afterthoughts to one extent or another, and that's meant that getting it integrated into how people work and think has been a gradual process. But environmental engineering is further along than security is, so we can make use of that. In particular, if you look at the accreditation requirements for engineering programs, mechanical engineers, chemical engineers, any type of engineer who graduates from an accredited program is supposed to graduate with the understanding of how to do their work in an environmentally sound way. They're supposed to understand how to design sustainably and what the environmental engineering issues are around their work. And that's just a thing that now employers expect of them, and that the professors know to prepare them for. And it's not like an unusual thing anymore. It's just a thing you should have if you're a qualified engineer. And this has been a gradual change, but you can definitely see it now. The environmental engineers I know say they get more and more questions on their research from students who aren't in environmental programs. The professors are placing a higher priority on it in all disciplines, not just in the engineering programs for environmental. So this is all great positive change, and I think it's all totally doable for security as relates to computer science. So, is anyone doing it? Oh, right, sorry. I was going to revisit those ABET curriculum requirements, because this part in particular is very glaring, I think. So in case you don't know, ABET is, I think now they're just ABET, but it used to stand for the Accreditation Board for Engineering and Technology. I think they went the way of ATT, and now they're just letters. But but anyways, they're the people who decide for engineering and computer science and technical programs what qualifies as an accredited program. And I know not all good schools bother with the ABET accreditation program, but it is still the standard, the most prominent one I know of in the US. So it's still, it sets the expectations. And if you look at the general student outcomes for all engineering programs, it has a criteria that students are able to design a system to meet desired needs within realistic constraints. And then they list like 10 of them, one of which is environmental, but also economic, social, ethical, lots of really reasonable, realistic constraints. These are just this is the part that says engineers design systems that have to work and function within the real world, so they have to make things with that in mind. And, that's a pretty tall order, but, it's what they do. And there's another section that basically says that they need to be able to evaluate designs with those realistic constraints in mind. And if you look at the requirements for computer science programs, the wording is extremely similar, except with a pretty glaring omission, which is that we get the part about how they have to design a system to meet desired needs, but then there's no reasonable constraints. Forget like just security and privacy and stuff like that, but none of those other reasonable constraints are in there either. And what this implies is that we're treating computer science more like a pure science than like an engineering discipline. That the expectation is that the majority of students are going to go into jobs where they're not creating systems that have to work in the real world. And while some professors might prefer that to be the case and they wish they were teaching people for that, if you look at what the majority of students actually do with their degrees, it's not a realistic assumption. And I think that's, a problem in how we're approaching this as a whole. I mean, one of the goals of education is to properly prepare your students for what they're going to do with that education. Yeah, it's for all computing majors, not just specifically computer science. I have a little, but there's a lot of different standards. I haven't that much. If you have any pointers for me afterwards, I'd appreciate it. And so it's just this whole thing where it's like we're holding computer science students to a much lower standard. I feel that we need some reasonable constraints. It should have privacy, reliability, security, and probably a bunch of other ones. But anyways, so is anyone doing this yet? And on a broad curriculum-wide level, not that I know of. Again, I welcome examples afterwards, but I looked and it doesn't seem like anyone's doing it in that sweeping sort of way. The closest I found so far is the ACM 2013 guidelines. ACM puts out curriculum guidelines every few years. In 2013, it was the first year where they had an information assurance and security knowledge area, which, bravo for adding it, but also maybe a little late to the game, but that's okay. Better late than never. They introduced security as an integrated topic rather than something separate, which is good, although I always feel like you're more successful at something if you understand the reasons for doing it. And they're not valuing integration as a goal in and of itself. From my reading of it, it's mostly just because they don't want to give up any other course time. And so they're just trying to figure out a way to work in the security minimum stuff into the other things. And, it's just not as effective as it could be that way. And also, while they do include a lot of practical security concepts, they're generally labeled as familiarity rather than usage, which to me says that it's more about conceptual understanding, maybe a lesson or two, but not something that students are supposed to become really comfortable with and use a lot and make a part of their working life. So it has some things to recommend it, but I just don't think it's quite there yet. What do I think we need is a thorough, complete integration of security into curriculum, but in a way where we can get the maximum impact possible for minimum changes to original coursework. Because if you make it too hard, people just aren't going to do it. And I really think that with some subtle changes, we can achieve great things. In particular, changing the way we ask questions and the way we present topics to people can make them aware of when a security issue is at hand. Sometimes we already teach them things that are relevant to security, but we don't go to enough of an effort to make sure that they notice when that happens. And so then they come through without an awareness of what the security concerns are for their work. My first example of how to do this is from algorithms, because that's my background and, stick with what's familiar. But anyways, so this sort of problem, this is one I got from University of Montana, but you've seen stuff like this before. It's just applying a mod 13 function to letters for like a really simple hash table. And then they asked the students a bunch of questions about them. And one of the last questions they asked was about the worst case runtime, which is something you discuss a lot in algorithms class. But the phrase worst case runtime is one that implies like a causeless bad luck sort of scenario. You know, it's oh darn kind of thing. And a worst case runtime is a vector for a denial of service attack. It is in pretty much any scenario where you're taking user data. And students don't know that when they graduate. They have to figure it out the hard way later on. So ask the same question, get the exact same answer back, but when you ask it, say, if an attacker wanted to slow operations down, what's the worst runtime they could force with their denial of service attack? You know, give an example of an input that would achieve this. How would you how would you change the function to avoid this vulnerability? It's the exact same questions that they were already asking. It's just now the student knows it's a security thing. And if you did this consistently every time you brought up worst case runtimes, students would learn that good reflex behavior of just wondering about, oh, am I opening myself up to a DOS when they're doing algorithmic design work? You know, that's what you want, is for them to ask themselves the right questions after they leave your classroom and they're doing this work in the field. So, another example is from a networking course at UCSD. And again, this is a sort of problem I'm sure you've seen in lots of course material. They gave the students a simple network diagram and asked a lot of questions about, you know, if somebody in AS3 wanted to send traffic to AS2, you know, what would they advertise, blah, blah, blah. You know, like the pretty basic stuff. But the thing is that all the questions that we normally ask in this problem are the positives of the algorithm. It's all about how does it work and how do you use it. But tools have limitations, and where in other engineering disciplines we make sure that people understand that and learn about, you know, how things handle stress and how things break and all the rest of that sort of stuff, we tend to have a blind spot in our education and computer science where we don't ask the negative questions. So, you know, you just add a part E and F to this where you say, suppose AS1 wants to hijack traffic destined to AS7. What routes could they advertise? Or you say, if someone sees their own AS listed in a path, they'll disregard it as a loop. How could that be used maliciously? And this is not adding a lot to the coursework. You don't have to take out material, but by asking these sorts of questions, you train students to think about what the limitations are of tools. And if you do this consistently every time you introduce a new protocol, then they'll learn to do that when they're, you know, looking at new stuff later in their working life. And, you know, it's just that consistency, I think, is the key. Because people don't learn how to do things the right way from just doing it once. They learn how to do it the right way from repetition and getting drilled on it so often that they're just sick of it, you know. So, what would I like to see happen? Security is a part of every computer science topic, so it should be a part of every computer science course. And introducing a concept once isn't enough. I mean, teaching people how to validate inputs on one homework assignment is a thing you should do, but then from that point on, if they don't apply that lesson to their other homeworks, whether you told them to do it or not, they should lose points. Because if these sorts of problems in there if they don't have any negative repercussions for making these mistakes when they're in the classroom, they'll learn that those things don't have negative repercussions. And doing it as just a single-time exercise teaches them that this is just a special event kind of thing. This isn't something you have to do all the time. It's just something you have to do when somebody tells you to. And that seems to be one of the biggest problems with how these systems get integrated, that even when people know how to do the right thing, they don't recognize that this was a situation where it was called for. They understand certain security concepts, but because that wasn't the first thing on the list of what they needed in this scenario, they just forgot that it was needed at all. Okay, sorry, I had a little tangent there, but repetition is the key. So every time you talk about how a protocol works, you should follow that up with how it doesn't work. And anytime you talk about worst case runtimes, you should talk about DOS. And, intro level classes should, as much as possible, have applied examples and applied content in the homeworks. The best way to learn how something works is to learn how to break it. So, people say that, oh, but we're going to have to lose material in order to do this, but I really feel that including meaningful security content into these courses will only give students a better understanding of these tools as a whole. And non-security programming homeworks should be subjected to whatever tests you can come up with to subject them to. It's just, pain is how students learn, so, in fact, Ed Felton told me that Princeton had a class where all the assignments that the students submitted were subjected to pretty brutal fuzzing and attacks. And if you dumped core or had a segmentation fault, you get major points off, maybe even get a 0. And that's what would happen in the real world. So. Because at least when I was in school, and I think this is true for a lot of people, students get to that mindset where once it compiles and outputs the number I wanted, I'm done. And, that's the mindset we need to sort of break people of. So, application, not just theory. Conceptual understanding is great, but it's putting things into practice that helps students learn them. So, it's just... they have to learn how to make these things part of how they work. Because, if they just learn about them in theory, they might even know they should be doing it and just not know how. And we don't want people in that boat. In particular, I've had a lot of times where people came to me and said that they basically had this feeling of unease and dread because they were pretty sure they should have some security worked into whatever thing they were doing. And they just don't know the first thing about how to go about that. They know so little about security that they can't even articulate to me what their problem is. And that's a thing, too. I mean, it's not like they're going to be able to solve every security issue, but they should be able to recognize when they're in over their heads and also be able to articulate to somebody else what the problem is so they can find and hire the right expert to do it. That's an important thing. And, just a little side note is that as security becomes a bigger part of your curriculum, it's important to make sure students know how to do security research safely and legally, and you have a responsibility to your students when this comes in. In the classroom, you'll create sandboxes for them to work in so that they can do it all, but those sandboxes are great for encouraging intellectual curiosity and creativity. But you also have to make sure they understand that it's an artificial environment, so they don't leave there with like a, hey, what does this button do kind of mentality. And, it's just a lesson I've learned from particular buttons that shouldn't have gotten pushed. But anyways, so back to the theme. Subtle changes, big impact. It's just about trying to figure out how to present the material in a way that increases student security awareness and how to work in those basics that they definitely should have. I mean, I've had office mates who are database developers who didn't know what SQL injection was, and we just can't have that. The important thing is to try and teach these things right from the beginning, because how somebody first learns something is how they're likely to always think about it. Course correction is sometimes necessary, and you can try to do that, but it's never going to be as effective as getting it right the first time. And the only way to make security integral in people's work is to make it integral in their education. So, looking at those student outcomes from before, what do I view as the requirements for somebody being able to design within the reasonable constraint of security? I think students need to understand the security basics of their chosen field. They need to be able to evaluate the security of their designs with regards to those basics. They need to be able to recognize when they need more help, when are they in over their heads, and then when they find that themselves in that situation, they need to be able to describe the problem sufficiently to find the right help. Yep.
How would you feel about having like the security students, pen test students, evaluating grade computer science programs?
I mean, I think that's that sort of thing is a great way of giving the security students the experience they need and limiting how much extra effort the professor has to go to in order to implement these new changes.
Well, then we build up a dynamic now, and then they both cross-train each other.
Mm-hmm. Yeah, and those sorts of solutions definitely have potential.
Are the students going to fix it afterwards, or like real life, just let it go?
You know. So what those goals all sum up to, in my mind, in short, is making people responsible for the security they're capable of handling. The securing all these systems and technologies is a huge job, and as long as people go into this with the attitude that it's solely the job of the security experts to do it, they're never going to be able to make headway on it, and that's the big problem here. Everyone else needs to learn enough to be able to get out of the expert's way. And then all these security experts that we're training up will be able to actually do the work we train them to do. And maybe we'll be able to make some headway on all of this. And I really think that spreading responsibility where appropriate is the way to start moving forward. It's just too frustrating to see these same things continue year after year and decade after decade and just, So that, I think, is just the key. My next steps, questions I need to answer, that sort of thing. The first and biggest is just the thing that a lot of non-security computer science professors don't understand the security issues of their field. That's why they don't teach it yet. And so we need to develop course materials and training materials to enable them to teach it correctly. We need to try and work on getting ABET to fix these criteria discrepancies. When I asked how the environmental requirement got added in, they just said that people bugged them until they did it. So, apparently that's that's the way forward. And encourage ACM to further integrate security into core curriculum. And figure out how to start moving forward with more concrete stuff. I would like to do some A/B tests in big classrooms and big intro-level computer science classes where we teach a new updated course to half the sections and the old stuff to another half, and be able to test at the end of the semester to figure out how the new material did. Because the way to get wider adoption of these sorts of approaches is, of course, to have data proving it works. So I am, looking for classes to partner with. And yes?
So you listed more things on that slide. So at least two of them are about curriculum requirements.
Mm-hmm.
So having served on a undergraduate curriculum committee that was charged with meeting, ABET requirements.
Mm-hmm.
I can tell you, not my university, but certainly, I've heard that many universities curriculum committees are really, really skillful at figuring out how to explain that they are meeting a criteria without actually doing it at all. Now, my university would never do this, but I'm told that a lot of other ones do.
Well,
What's important is making them really want to include this in
Yeah.
the curriculum. And having it be a requirement does not accomplish that.
true, but I mean, I still think at some point it has to become a standard. But
Students not getting hired.
that might be a better way. And like approaching some of these big corporations that have to retrain all their incoming programmers and getting them to instead put money into try and getting universities to adopt this approach so that they don't have to have that continuing expense is another way to approach this. Yeah, Sandy?
Well, I actually have an observation that underscores how important the first point that you bring up there is.
Mm-hmm.
We had a new grad student this year who is a budding hacker, and I hope to bring him to these. But he was messing around with one of his required coursework homework turn-in systems and found a security vulnerability. And he approached the particular professor whose course this was and who designed the system and said, I found this bug in your system, you might want to patch it. And of course the professor said, great, I'll patch it, but security's not my problem. I don't teach security.
Yep. And yeah, the bugs in autograders are an issue. Maybe students get some extra points when they. If he didn't, then he's not very good at it, I guess. I don't know. Yes? Well, I mean, ethics training, I believe, is necessary in any technical discipline. I mean, I took a whole course as an undergrad on the ethics of modern science, and there's certainly been enough failures in ethics of modern science. But I think that ethics training in general would teach students, at the very least, why they should care about privacy in their systems. Why they should care about protecting their users. Yes, sir.
You mentioned the survey that you put out to your professors. Was that published?
No, I mean, I have it in my backup slides, and I can, but it's not published right now.
Were you planning on redoing it again at another time in the future to compare to see how much of what they've been integrating from computer security has been actually improved, or if they're getting the same response?
I don't want to bug professors with surveys so often. Oh, right. He wanted to know if I had published my survey and if I plan to re-administer it. And I think I don't want to become the person that they're sick of hearing from, so everyone stops responding to my survey. So I was going to wait until I really had some new questions to ask them before I send out any new surveys. Yes?
I don't know the answer, but if you look into the curriculums in China, Russia, Iran, and if you found that in those countries, universities pay more attention to security in computer science,
Mm-hmm.
then we could use it as a lever to shame American universities.
Yes, and if anybody knows of better work on computer science curriculum design in other countries that they can point me at, that's very useful too, because any course materials we don't have to develop from scratch are terrific.
But maybe just by looking online we find it.
Mhm.
I have a follow-up suggestion.
Mhm.
Some professors may not know how to include it, but some book writers, textbook writers, who add some exercises into their textbooks,
Yep.
and they can work with the security professionals.
Yeah, and
Some new exercises to help professors.
And new textbooks that integrate these topics into general curriculum materials is definitely one way of addressing that first issue of how to equip professors to teach stuff that they don't understand well enough currently. I don't work in the textbook publishing industry, but if anyone's excited to do that and does, then that's exciting too. I think having textbooks that present the material properly would be a huge step. Any other questions? Yes?
Very, very common that professors will give us like example code or whatever, which is vulnerable to obvious things. And when we point that out, they actively try to avoid caring. Is there anything we can do to try to make this not the case where this horrible practice is being
So, so the question was about as a student who has professors who seem not to care about the security problems in their own example code or what have you, how do you get them to care? And I will say that if you are a student, be careful about pissing off professors too much before you get your grades from them. But just because, caution and all that. But that's an interesting problem. And I think one of the main ways to get professors to start caring about all this is for employers to start, picking the universities that handle security education better as their sources of students, because employability of your students is important to professors, or at least the good ones.
What we used to do was fix the teacher's code, hand it back in, and the first 5 pages of documentation is just about what's wrong in the code and why aren't but
Yeah, I mean,
eventually that
helping them out is good, rather than just being like, oh, that all sucks. Yeah.
So I'm assuming your survey results were confidential. Otherwise, you could tell us which two universities actually integrate security in their whole program, so we can put their resumes on the top of the list.
I promised anonymity, so I guess I could go back and ask them whether I could. But yeah, I did promise anonymity. And one of the other things I did for getting better survey response was that I offered to provide all respondents with the anonymized results of the survey so that they were getting something out of replying, which is a useful tip. Yes, sir? And yeah, there is a general problem where because people have a security program established, they feel like their job is done. And the whole point is that training up future experts is terrific, but you shouldn't, in doing that, neglect the security education of all your students who are going to have other specialties. Both jobs are important, because, having environmental engineers is good, but you also need your average chemical or mechanical or other type of engineer to know how to do their work with some modicum of environmental concern and sustainability. Yes?
Okay, so I'm may be risking death by people, but I'm also one of those academics who's leading to the graduation of malware-ready coders in the future, and I'm trying to reform. But all security is an education problem, and everything you've said is right, but educating the educators is really difficult.
Mm-hmm.
We have a new faculty member, Berkeley PhD, database person. If you ask about injection, cross-site scripting, cross-site request forgery, her eyes will glaze over. She doesn't know what you're talking about. So this is a real problem that you've identified, and the questions are all right. And I don't know any of the answers. The ABET, the IEEE ACM curriculum has 25 hours, lecture hours of security in the entire program. So that's less than half of a one semester course. This is a real problem.
Yeah, educating the educators is a big issue, as this gentleman pointed out. And I think a lot of times smaller universities or ones with less built-up computer science programs borrow curriculum from more influential schools. So I think getting some adoption with those more influential schools, so people start borrowing material that's better designed with security in mind, would be a big deal. Yes, sir?
I was just thinking about what you were saying. Has there been any partnership or suggestion of a partnership between OWASP and maybe, let's say, ACM, as far as maybe making some recommendations for things or ways they can actually reduce risk for capability students who are taking training? I mean, as an example, teaching computer science students when they actually take input to do validation, what does that look like?
Mm-hmm.
Plain simple. If you aren't doing
Yeah, partnering with the curriculum design guideline people would be terrific. I don't know how much headway I would make on trying to partner with them as just me, because I'm not associated with a university, and sometimes you need that. But I have been working on partnering with friendlies at different universities that I already have associations with, so that we can try and get some pilot programs together and start developing curriculum and figuring out how to teach this stuff so that we have material to bring to those sorts of people. Yes?
As a comment, AVET does have accept industrial representation for their program evaluators as well as educators. So if any of you are interested in the AVET, volunteering for AVET, become a program evaluator, you can go out to their website and look under, and it's just avet.org, look under volunteers, and there's some criteria about what you would need to be able to do. But there is definitely a need in AVET for program evaluators from industry. You can go for CSIP and IS.
So she was just saying that ABET takes industry volunteers for evaluating programs, and that she encourages people to go to abet.org to look into that if they're interested. Yes, ma'am?
One way to incorporate it in the networking classes is to ask people to read the security sections of the RFCs
Mm-hmm.
and ask them why the section says what it says, and maybe ask them is this section complete. So all RFCs now must have the security section.
Mm-hmm.
And just like the ITF has mandated it, the networking classes can try to include it in this security.
So she was just suggesting that one thing for networking classes could be having a reading exercise where you look at the security section of RFCs and try to figure out things that they missed, or try to decipher why they have requirements in there that they do, which could definitely be a useful exercise, particularly in the well, I don't know, at least when I was at MIT, they had computer science classes that were specifically focused on learning how to read technical documents and that sort of thing, and integrating security into there would be good too, rather than just learning about, fatal programming flaws and fun stories like that. So, any more questions? Yep.
So you talked mostly about undergraduate integration. Has there been any push to integrate it into graduate curriculum, requiring a security professor on a defense committee? That would seem to solve the birthday problem a few minutes ago.
Well, so he was asking about my focus on integrating into undergraduate curriculum, and has there been any work on focusing on graduate programs instead? The main reason why I'm focusing on undergraduate programs is because if you look at the numbers for where students are going after getting their undergraduate degree, the vast majority of undergraduate computer science students are going into more engineering type jobs. But
That makes sense. I'm talking about the free integrate.
oh,
That's the problem. You fix the professor by fixing the
and focusing on graduate programs would help on producing professors who are better able to teach this material. It's just I had to pick a target to start with, so I picked the one that I thought was biggest influence. But if anyone else wants to get on that, then all power to them. I'm just me. How are we doing on time? Oh, okay. So, yeah. Well, any other questions offline then?